There are things that should be in everyone's toolbox. For breadboarding, this little resistance decade is a nice form factor. It's not too big, it has this little push thumb wheel switches and just a little wire. It's all 1% SMD resistors, and well, it's really a handy, nice tool for breadboarding. But today we are not going to look at this little one, but at his bigger cousin. So this one I got from eBay for about 38 bucks delivered, and it is obviously a resistance decade box, and it does not only look old, but it is old, but that usually doesn't matter. Resistors do age, but the really good ones do not age that much. Time wasn't so nice to this thing. There's a lot of scratches, and well, there are stickers on it, residues. There are actually some stickers on it. I have no idea what they were for. Just like our little box, we can select every digit of our ohms value directly, but we have these really nice and clunky switches. They go from 0 to 10, so we have 0.1 or 100 milliohms, 1, 10, 100, 1000, 10,000. So we can go up to 111,111.1 ohms, and this value is only valid at 20 degrees Celsius, which we can see here. And this is the material this thing is made of. Manganese is a trademark since 1903 for an alloy of a little bit over 80% copper, a little over 10% manganese, and the rest 2 to 4% is nickel. It has a rather high resistance and a really low temperature coefficient, and the coefficient is rather linear. Quite an ideal material. And also I doubt that this box is from 1903. This one was actually on eBay as measurement device with handles and no further description. So a lot of these boxes go for much more than 38 euros, and if you want to get something that people do not know of, think a moment about what they would describe them on eBay, and they usually don't know that it's a resistance decade, so you won't find them when you search for resistance decade. So these are the handles at the side, just as the description said, and it has some nice rubber feet on the back and on the bottom. So this is a plate on it. It says Pretzwiderstand, which is an abbreviation for Präzisionswiderstand, which means precision resistance. Manufactured by Siemens in Germany for the German market. And well, here you see how everything is wired internally, just in case it is not obvious to you when you open it. And for the 100 milliohm resistors, the precision is 0.1%, and for all others it's 0.02%. That's not really metrology grade, but it is pretty decent, and you should be able to calibrate most common multimeters against it if you want to. And that's pretty much what those things are for. They are not for using a breadboard, and you really don't want to destroy them by running too much current through them. Below it says that you should clean the switches with petroleum, and then you should put a really thin layer of Vaseline on them. That's probably the model number. So let's take another look at it before we open it. It says here what the maximum amount of current is you can run through it, and you have 2 amps on the 100 milliohm, and usually those things are rated so that when you run this amount of current through it, they don't heat up too much to go out of spec, so you can expect quite beefy wires on the 2 amps range, and here you have 10 milliamps on the 10K range, so they are not as thick. So let's open it. It's really nice screws here. So front panel easily pops up, and we can see a 4 on it here, and I don't think you can see it here in the camera. There maybe there's a Roman 1 handwritten on it. No idea what this means. They're really nice clunky switches. We have some screws here that we will open. So if we look down here for a moment, there's a little lead seal with a old Siemens logo on it, and I really hate to break this, but I think this is already out of warranty, and this is probably mostly so that we can be sure no one tinkered with it and it's still within its original calibration. So let's open that seal. Here we go, that's the Siemens logo, and let's run through 2 of these screws. Let's take off the second one. This will take off this little plate which is over the last screw. And it looks like that one hasn't been opened in decades. Lots of decades. Okay, screws are out. So let's take it out. Whoa! It's pretty heavy. And whoa! I mean, really, damn heavy. Even has a rubber sealing on it. Wow. It's really brittle. Oh. If you look at it, it was glued down. Ooh. The whole plate here seems to be some heavy plastic material. So let's turn it around. It weighs a few kilograms. We can see here the big copper bus bar like thing, and it goes down to the obviously milliohms range here. I mean, look at these wires, probably hand cut to just the right length. And then all those here probably hand wound with manganese. And then all handwritten, the actual numbers on it. And then solder to these thick wires here to not introduce any additional resistance. And you can see over here the really big versions, like that thickness approximately for the 1 ohm, and then it gets a little bit thinner for the 10 ohm, 100 ohm, 1000 ohms. And really, I mean, these are probably all enameled wires. And then they like put these sleeves on there. It's not a heat shrink. I mean, probably they didn't have heat shrink back then when this was built. It looks like fabric. You know, just like these sleeves that you can find on modern wires and need to withstand some heat. But get this, there's some residue on there. Don't know. So let's us get this out of the way and have a look into the box itself. Oh, one of the knobs fell off, but that's no big deal. We're going to disassemble it a bit anyways to clean the contacts, and so yeah, nothing more in there. Something's written on it, like 50 here, probably the same one as on the cover plate, and this is MREF1 stamp, so maybe it's revision 1 of the wooden box. I don't know. I might actually... Siemens has a museum of all kinds of stuff, so I might actually ask there and let's see if they know something about this resistance box. I don't know if you can read it there. It's 20th MRZ, that's German abbreviation for March. And I think it says 53, so that would date this thing to 1953. Let's have a closer look at the actual switches. This is the number 3, so we go from 100 milli, 1 ohm, 10 ohm, 100 ohm. You find a lot of maybe more modern, I don't know, but a lot of resistance decade switches that have like little discs with 3 or 4 wipers going to it, and on the other side a bar, and it basically connects the bar to plates. Yes, this one is quite different. I actually like this one a little bit more. If you remember the milliohms one, there we saw a star of 4 wires going from the bus bar to 4 points on this inner ring, so that there is a minimal distance from each position on the inner ring to every single position on the outer ring. So there's still some grease on there, and let me see if I can clean it up so we can see how much wear there is. So I got the camera down here, and so we can have a closer look, and there you can see some grooves of the contacts, and you can count like 2 here and 2 there, and it looks really like a little bit of wear, but if you go over there with your fingers, it feels really smooth. So I will probably just clean everyone up and put a little bit of, well, don't know if Vaseline is really the best, but something like that on it. If you have a look, it's of course a make before break switch, so that you don't lose any contact in between, so that you have a smooth enough transition and you don't get an open circuit in between. Some instruments don't like it. Yeah, if you have a close look, there is some spring mechanism holding this down here, putting pressure on those little tabs. So it seems that these two outer tabs are responsible for the outer groove, and then there is an inner tab that's responsible for the inner groove. So we have a 3 contact switch here, and as far as I can see, it is the same on the inside switch. So on the actual switch knob, we have this coincidentally omega-like form that goes down on this here, and if you have a closer look, it can be adjusted and then turned around, held in place with the screws here, and it's probably all well, switches made for very general purposes of these kinds of instruments, and then adjusted to whatever need. A little nice handwritten 3 here. And yeah, I don't think I will take it apart any further. I would hate for one to damage it, and it really isn't necessary. There isn't much more to it. I attached my really unworthy old manual ranging 3 1/4 digit multimeter. I don't really have anything better, so if anyone wants to send something to a needy computer scientist, feel free to give me one that matches or at best exceeds the performance of the thing, so we can maybe one day measure if it's still within spec after all these years. I mean, 1953, that's older than my mother. Whoa. So have a quick look. If you didn't notice before, the actual numbers that I've written on the dials here are always the other way around, on the top than on the bottom, so that when they're in the windows they all look nice. So let's have a look at the 100 milliohms range. The actual resistance of these wires and uncertainty of this multimeter is like 300 milliohms, and well, that doesn't really matter as long as we add roughly 100 milliohms with each dial. So 6 plus 3, 900, go to 1 ohm, so we are 1.3 ohm. That's really nice. So to make it look nicer, let's put 7 on here. Huh? Sometimes you have to handle them a little bit. Yeah, that looks pretty nice. So we are on 1 style, 2 ohm, 3, 4, 5, and for the last one we should read spot on 11. That's nice. So let's take the 100 ohm. We are on the up to 200 ohms range, so we can dial to 100. It's 101 because of that one. Let's add 10, so we are 111. Oh, that's 0.1. That's really nice. I mean, the switches really feel nice too. 41, 80, 90, 200, and we are out of range because 200 means anything lower than 200. So let's have a look at the higher ranges. Put that to 0 because we won't need it there, can't display it. So we can go up to 100k with that one. So let's take a big range here. So 10k, and I'm really sure it's the multimeter that's off here. Let's add a little bit so it just looks nice. It feels nice, it sounds nice. It's almost like those switches have an echo. Ohms. So I'm sure I should calibrate this multimeter using these. I mean, even if they are way out of spec, like spec is 0.02% and they are 0.05% or anything, I mean, that's 0.1%. Like displaying like 0.3% off here, so even if it's 0.1% off, and I really doubt, I'm really sure it's still within spec, we should be able to nicely calibrate this multimeter after it. And the multimeter is actually within its own spec with like, I don't know, 0.5% and more in the upper ranges. Yeah. So that's it for today. A box with resistors.